everybody. My name is Miss Simmons, and this week I'm going to talk to you all about genetic disorders. So, a genetic disorder, we know how genetics works, and genetics or traits are normally passed down from parent to offspring. And in genetic disorders, we have different types of diseases or complications that are passed from parent to offspring. And there are different types of ways that genetic disorders are passed down. There are some that are autosomal, and that usually requires either one single gene or multiple genes. We have sex linked genes that can be passed down, and chromosome abnormalities. All right, and we're about to get into each and every one of these. Now, with autosomal genetic disorders, this is usually caused by some type of mutation on the autosome chromosomes. All right, so you have 23 pairs of chromosomes, and your autosomes are chromosomes number 1 through 22. And that 23rd set of chromosomes is your sex chromosomes. Now, we talked a bit about recessive genes and dominant genes. Now, most genetic disorders are recessive, which means that you need two of the recessive alleles in order to show that disorder. Now, there are some people who would have just one recessive allele, which they would be considered heterozygous. So they would have one dominant and one recessive, and those people are called carriers. Now, even though they don't have the disorder, they can still pass it on to their children. All right, so some examples are cystic fibrosis, which is shown down here in this picture over here. All right, and this is some disorder that happens when your body produces a lot of mucus in your lungs, and it makes it very hard for you to breathe. And these people have very low, very short life expectancy because of that. And also another one is sickle cell anemia, which causes the blood to create this weird sickle cell shape. All right. Now, there are some disorders that are dominant, which means that they only need one allele to have this disorder. So those are things like Huntington's disease and even dwarfism, which is shown here to the left. All right. Fun fact, that's my favorite show. It's called Little Women LA. All right. Now, there are some that are controlled by multiple genes. Now, we talked about sickle cell and cystic fibrosis and Huntington's disease. Now, those are controlled by just one gene. Excuse me. Now, there are some disorders that are caused by multiple genes, it means that they run in the family, but they're not exactly sure how they are passed from parent to offspring. All right, so these are things like diabetes and heart disease and even bipolar disorder, schizophrenia. All right, now they are way more complicated to analyze and to study because they are caused by more than one gene or more than one factor. Now, in sex-linked disorders, this is when you have some type of mutation on the X chromosome. So hemophilia is one, and red-green color blindness. Now, women are mostly carriers, or most often carriers, but men are not. And the reason that men are not carriers is because if you look at the genes that they carry, so women are XX, right? So they have two X's, and men are XY. Now, if a person is, or if the mutation is caused by an X chromosome, well, women have two X's to help back them up. All right? Men only have one. So if there's a mutation on this X chromosome, they can't do anything about it. They're automatically affected by it. All right? So if you look down here at this pedigree, you'd see the solid blue represents someone that is affected by the color blindness. And normally, women are not affected by color blindness. The only way that women actually inherit color blindness is if both parents carry that colorblind trait. So if you look over here, right down here, you see that one parent, which is female, is a carrier of this trait, and her husband, or the father, is affected by color blindness. So down here, of course, this man is affected by the color blindness, and this one is a carrier of the color blindness, and this female here was actually affected by the color blindness. All right. Now, with chromosomal abnormalities, we normally see either autosomal or sex-linked disorders that can be affected by both of these. All right. So one of the most common ones, well, first let's look here at a normal karyotype. So we have our 23 sets of chromosomes, and this one here just so happens to be a guy because he has XY, right? The rest of these chromosomes, 22 all the way up to chromosome 1, those are called your autosomes, all right? So our abnormalities can happen on either one of these chromosomes in your karyotype. Now, focusing over here, chromosome 21, each set of chromosomes should usually have just 2 chromosomes. You get one from mom and one from dad. But this set here just so happens that this person, or he, actually we just confirmed here, ended up with 3 chromosomes on chromosome 21. Now, because of this person is considered to have Down syndrome, which is called trisomy 21, which means that they have 3 copies on chromosome 21. Now, there are some abnormalities that can happen on the XY on the sex chromosomes. There are some people who have 3 chromosomes on their sex chromosomes. Now, this person is usually diagnosed with Klinefelter's disease or Klinefelter syndrome. All right, and typically with this, it is a guy, but they also have female features. So they may have less body hair. They may grow breasts, and they're typically infertile. All right. So what's next after this? What you guys are going to do is check back in Google Classroom. There is a quiz there for you to complete, and also some activities. You can complete either option A or option B. All right, I just want you guys to make sure that you are checking back into the master document to see what options are there for you to do. All right, have a great day.